and seismology creates earthquake-resilient societies. Fabrice Cotton, GFZ, German Research Center for Geosciences.
On November 9th, 1989, I was a student, and me and a dozen friends spent hours concocting improbable plans to skip lectures and head to Berlin, which made it a city of freedom, and I've been happily living here since 2015.
In February 2023, 9 months ago, two large earthquakes of magnitude 7.8 and 7.5 have been shaking the eastern part of Turkey and the northern part of Syria. More than 60,000 people have been losing their lives during those earthquakes. Hundreds of thousands of buildings have been damaged during these earthquakes, and the damage which have been occurring are occurring in an area which is about the size of Germany. In the following minutes, I will try to discuss with you if such a disaster was really a surprise from a scientific point of view. I will try to evaluate also with you what we have been missing in order to reduce the impact of such earthquakes on our societies, and I will try to discuss the future of earthquake prediction. But why first do buildings collapse? I think an earthquake is due to the sudden slip on a fault which is located at depth. Due to the sudden slip, waves will be propagating from the depth to the surface. Those waves will be reaching the buildings, and if, and only if, the buildings has not been built to resist to this horizontal shaking, the buildings may be damaged or even collapse. In other words, earthquakes are not killing people, buildings do. In order to avoid that, we are building models, we are deriving maps like this one, which are trying to evaluate where the future damage, where the seismic risk is the highest and where the future damage will be occurring. I show you here a map which is a result of the work of hundreds of researchers which have been derived in 2020. In order to derive these maps, we have been evaluating where the active faults are, we have been evaluating what could be the size of the earthquakes on those faults, we have been evaluating the shaking and the impact in terms of fatalities and financial losses of the earthquakes. I think you clearly see that the eastern Turkey and northern Syria was already identified as a high-risk area. But let's go into the details to understand the lesson learned from those earthquakes. I think first, where the faults which have been rupturing in 2023 known? The answer is yes. You see the lines, the red lines, which are showing you the faults which we are using in our 2020 models, and the background is satellite images, and the interface between the blue and the red is showing you where the fault has been slipping in 2023. So we knew the faults, and those faults have been slipping in 2023. Where the earthquakes larger than expected? In the scenario that we were considering in 2020, there was the first earthquake, 7.75, which is in fact very close to the earthquake which had been occurring in February. And there was a second one, magnitude 7.6, also again, very close to what has been observed in 2020. So from an earthquake point of view, from a shaking point of view, from a scientific point of view, there are no surprise. But let's move to the impact of the earthquakes. Using the 2020 model, we also have been computing the number of fatalities which are associated to this kind of events. Of course, I show you histograms because the uncertainties are high. But if you have a look at the mean number of fatalities created by the first earthquake, 7.8, we have about a number of 13,000. For the second one, the number is 2,000. And here is the surprise. If we sum the two, the number that reaching 15,000 is about 3 times less than what has been observed during this earthquake sequence. Where is this discrepancy coming from? In fact, in our simulations in 2020, we were considering that the most recent buildings, the one built after 1999, after the later generation of the Turkish seismic building code, we were considering that those earthquakes were able to resist to this kind of shaking. This has not been the case for many buildings, and I show you an example of the resonance resistance in Antakya, a very expensive luxury apartment complex, and you see that the buildings has been collapsing despite the seismic building code. I showed you a second picture, a more optimistic one, which is showing you a building which is intact, a middle of ruins. You see that on this building, if we zoom, that there are 4 letters written, TMMOB. What does it mean? Our Turkish colleagues in the room may have already understood. This means Union of Chambers of Turkish Engineers and Architects. I think this is clearly showing that the expertise was existing in Turkey. And the reason why the buildings have been collapsing is not due to a lack of science or lack of expertise, due to the fact that some decision makers, part of the population, was not following those recommendations. What does it mean? It means that if we want to improve things, we need to build a shared earthquake culture. An earthquake culture which will be shared between scientists, decision makers, and citizens. How can we do that? I think I show you here 2 pictures which have nothing to do with earthquake. I show you here pictures taken after the election of the Pope Benedict XVI and the Pope Francis, and you clearly see that smartphones have been changing our life. So a fascinating idea which has been explored in the community for a couple of years is to use those smartphones as a way to improve earthquake prevention. And I think one of the most popular applications, which has been disseminated since 15 years now, is called LastQuake, developed by the Euro-Mediterranean Seismological Center. And I think what is fascinating, I show you the way the app is working. The app is working in 2 directions. When an earthquake is occurring, users can click on one of the images to document the level of shaking they have been feeling. In return, they will get advices on how to behave during an earthquake. They will be also decreasing their level of stress because they will be sharing this information with others, and they will be also receiving information from the scientists. I think we have been very surprised by the fact that many people are using now this application. And more than that, they are reacting extremely fast. I show you again the example of the Turkish earthquake in February, 7.8. In less than 10 minutes, more than 1,000 people have been reacting and documenting. Each point is showing you one user has been documenting the level of shaking that they've been feeling. We have been using those new data sets as a scientific input for new computations, and we have shown at the beginning of the year that we can use those felt reports to evaluate very quickly if an earthquake is damaging or not. I think actually to get an info if an earthquake is damaging, it takes 10 minutes. I think the more classical chain, which is far more complex that I will not describe, is taken 30 minutes to evaluate the impact of an earthquake. Which means that with this new type of methods based on users' reaction, we are getting 20 minutes more, we are giving 20 minutes more to rescue team to act after an earthquake. But also we build something which is co-constructed. We build a response where citizens are associated. And this changes completely the way we communicate with people. Of course, we would like to do better. We would like to be able to send an alert before the shaking is reaching the buildings. And so other apps and other colleagues have been developing applications where the smartphone that you have in your pocket is used as an instrument when the smartphone is charging. So the smartphone is used to directly record the shaking which has been generated by the earthquakes. This type of application, the oldest one is called AQN, Earthquake Network, crowdsourcing-based earthquake early warning system developed by my colleague Francesco Finezzi from the University of Bologna. And I showed you here what has been occurring with this application, again, in February 2023, again, the same earthquake, the first one, 7.8. 33,000 users were using the app in February 2023. There were about 50 active smartphones in the epicentral area. They are shown by the squares. And about 15, shown by the circle, have been triggered by the earthquakes, have been detecting the waves, P waves and S waves, which have been generating at the epicenter, shown here in red. Using those detections, an earthquake alert has been given after 10 seconds. I'm actually part of the team. We are evaluating the performance of this early warning, also its robustness, to know if we can apply it for future earthquake. And I show you some of the results that we are getting. I think I show you here in red, in the blue, the first curve is showing you the time at which the earthquake is occurring. The blue line is showing you when the alert is triggered by the smartphone and then sent to the users. And the other curves are showing you the shaking which is occurring in various cities of Turkey. Of course, if you are close to the epicenter at the top of the slide, the alert is not useful. The shaking is arriving before the alert. But if you are in the south, far from the epicenter, then you start to have an alert before the shaking is reaching your building. This is particularly the case for the city of Antakya. Remember, this Renaissance building which had been collapsing with 800 fatalities. The alert here has been given about 1 minute before the shaking was reaching the buildings. I think this kind of application, we are only at the beginning. Companies like Google are also working on this kind of development. But it's clear that in a couple of years, the field is going very fast. It's clear that in a couple of years, you all will have this kind of alert system in your pocket, and you will receive a couple of seconds, a couple of minutes before the waves are reaching your building, you will receive such an alert. Of course, it does not work when you are really close to the fault, and so our ultimate dream will be really to be able to have a conceptual models to be able to detect earthquakes days, weeks, months before they're occurring. I think I showed you here results which have been obtained by your team in Potsdam. Supposed to show a movie. But I think what we have been doing, we have been able to analyze the seismicity which has been popping out from 2014 till 2023. And we have been showing that, in fact, the number of earthquakes is increasing, the small earthquake is increasing before the main shock. What does it mean? It means that what we see is that before the main shock is rupturing, I show you time and distance along the fault, what we are seeing is that before the main shock is occurring, that small earthquakes are popping up and start to increase 8 months before the main shock. Of course, it's too early to use this kind of increased seismicity to evaluate that an earthquake is coming. It's too early to send such an alert. But I think with machine learning and the kind of machine learning that we are using, step by step we'll be refining and derive this kind of catalogs and detect that earthquakes are occurring close to the main shock and be able to send a warning. It will take time, but we are clearly on this way. So I am at the end of my talk, and I think I wanted to share with you maybe the 3 key take-home messages. I think the first way to improve seismic prevention is first to build safe buildings. And we are able to do that. We are able to predict where future strong shaking will be. Engineers are able to build safe buildings. We simply need to build a common earthquake culture in order that we are all working in the same direction. To build this earthquake culture, it's clear that we need to build a new relationship with citizens, with decision makers. And the use of smartphone and app participate to this shared earthquake culture. It's clear also that smartphone will help to get real-time information and early warning, and we will all benefit from those alerts. Finally, from a research point of view, we are just at the beginning to understand the preparatory phase of large earthquakes. We see some phenomena occurring before large earthquake, but we need a systematic approach, we need modeling, we need multi-parameter analysis in order to quantify and really be able to send alerts which will be robust and in order to save people. Thank you.